Cool. Amanda, you wanted to say an introductory word, if I remember correctly, before I start?
Absolutely. So good morning, good afternoon, good evening, everyone, depending on where you're joining us from the world. Thank you for joining us for today's live session for Hacknosis. We're A, excited that you're here participating with us, and B, we have a great session lined up for you. And with that being said, I'm going to pass it off to Arne to give an introduction and then take it away from here.
Cool. Alrighty, thank you, Amanda. So I have the honor today to present you a primer, is how I call the slide deck, about green coding. My name is Arne. I'm the CEO of Green Coding Solutions in Berlin, Germany. And what we do mostly as a company is we help other companies making software sustainable. So what does that mean? That means exactly that you look at the energy consumption and you look at the carbon budget of software. And we also do a lot of R&D, like working together with institutions like the Green Software Foundation, or here in Germany, we have something like a Ministry for Environmental Affairs, and we try to create products around them. And Amanda invited me to talk to you folks here from the hackathon because it's a part of the challenge, basically, to create awareness and transparency about medical devices and products in particular. And I have crafted a very concise slide deck for you today. So we will probably have a mini bit of Q&A. But the main idea for my talk today is that I want to give you all the bits and pieces so you can create something like energy and carbon awareness and transparency into the tools that you will be building in the hackathon. And also you can look further into what could be possible optimizations and where are medical products and devices particularly energy hungry, and you can focus on that in particular when you create something in the hackathon. So the slide deck will either be handed out, either it was already be handed out to you or it will be right after. So talk is mostly that you have heard it all from me in person and I give you some pointers to it, but I tried to make the slide deck in the form that you can look most of the stuff up and it should be very self-explanatory for most of the pieces that I will present. So without further ado, let's dive right into the slide deck that I've prepared for you. So first of all, let's start with a strong statement when we talk about sustainability, especially when it comes to the digital realm. Digital products emit physical emissions. And we as engineers who build these products, be it hardware or be it software, should contribute and reduce their climate impact in particular that they have when we bring them out to customers, to society, or into our own company. So to back that statement up and why this topic is relevant in the first place, let me give you all some backgrounds. I think you all have, everybody has its knowledge about climate change and how it is relevant and how we all have to take our share to get emissions down. But let me give you a bit of a background when we're talking about digital products and what they mean particularly for the ICT sector. So ICT stands for Information and Communication Technology, and this basically makes up everything that is our understood modern digital world. So it is the software products that we use. It is the hardware where it actually runs on. So this means data centers, communication networks, but also end user devices, for instance, your smartphones or your laptops, etc. If you compare that to the global emissions, how they are in different domains, it is about at least on average, it's about on average what the aviation industry uses in its total fuel expenditure in 1 year. So this is what you can compare it to the ICT sector. And although some people might claim that this is not a big chunk, although we are already, as I said, in between 2 to 4% what the sector makes up, you can see that we use more and more digital products. So everything runs on more and more products run on software. We use more hardware. We are even more connected than we used to be like 5 or 10 years ago. And when you make a prognosis into the future, different data shows that in the year 2050, we could be at a 30% share of the emissions, given as a difference to the 2 to 4% that we have at the moment, if we continue on the trajectory that we're currently on. So just given the prognosis, it makes total sense to look at the digital sector, not only because it's relevant at the moment, but because we will be at a problem in a very soon future if we use digital more, which is what we probably want to do because we can help other sectors to decarbonize, like the farming sector, for instance, or in housing. There are enormous potentials that we can live with digital, with AI technologies. But if we continue like that, we might have a CO2 problem. So that it might make sense to tackle it with green coding, for instance, at the current point in time. So what is green coding if I talk about it as a concept? And why has green coding chosen, for instance, software as an entry point to create these digital savings when it comes to carbon and when it comes to energy? Because you can make the notion that only the hardware uses the energy, right? So software is a digital product. It itself does not have an emission on its own, right? So physically that is true. Like there is no exhaust pipe on a Windows, right? Or an exhaust pipe on something like a Firefox browser. But it is not causally, it's not the case. So software is in this domain or in this world because we have a particular use case to solve, right? We want to browse the internet, we want to send a message, or we want to run a certain workload. So this is a use case that we have, which is then basically constructed into a software product in order to direct the hardware and the telephone networks or communication networks to solve this particular use case for us. So one could make the claim that from a causal point of view, we only create all these hardwares and ICT components in the first place because we want to run software on them. So typically when you solve a problem from the engineering point, it makes total sense to go from the causal relationship, right? And not just from the effect relationship, which would be the hardware effectively running, but why you use it in the first place. Because if you can get the intention down, how much you want to use in the first place, you have a very bigger lever in order to create savings or reductions later on. So the target audience is very clear. Target audience is the engineers and people who develop these software products and then in turn instruct the hardware to run them. And the relevance is also pretty given by saying that every modern product runs on software. So we have an extremely big lever in the ICT industry when we go through the software route. So this, just as an explanatory piece, is the concept of green coding. So we want to go from the software side in order to reduce emission of digital products as we have them at the moment. So the question is then, how can green coding help? So now having understood that software is the lever which brings us into the savings when we want to talk about digital products, there's multiple ways you can go. And let me just reiterate them quickly, but also, as I said, some of these slides are also for you as a reference. I will not go over every node, just so you have them when you look at it through the hackathon later on. So obviously a thing that comes to mind when you think about green coding is people associate it typically with something like algorithmically, right? You would change something in the loop or use a different programming language. So this is of course true. This is a part of green coding, but although it is the first bullet point here on my slide, it's actually one of the lesser or minor points. So saving something on the algorithmic level needs an extreme scale of your application. So for instance, an example, Amazon changed something in their compression algorithm for S3, and they had savings in the three-digit millions. I think this is how you say it. So 100 plus up millions. So this is what they saved because of their enormous scale. However, if you have applications of various sizes, it can be that a change on the code level is not necessarily enough for you to make a relevant change. So what comes here into play, especially if you think about medical devices who can be typically smaller because they have to be transportable, an enormous effect is something that if you go through hardware efficiency. So bringing a, for instance, medical device out to the customer, design it in that way that it can be updated for an extremely long time. So it doesn't have to be replaced very soon, because if you think about, for instance, like a smartphone, for instance, has 80% of its CO2 emissions over a certain lifetime already in the production phase. So the energy that you use to run it is comparatively small to the production phase that you have it in the moment. However, if you run a server like Netflix, which is constantly streaming, something like 80% is in the usage phase. So it depends very starkly what kind of product you're having. Like, do you look on the, let's say, delivery side in the data center or on the actual device side? And you can have very different carbon budgets, for instance. Green coding has also very special carbon-aware computing techniques, and I will tell you some later on. Just take this here as a given for the moment. But also, and I think this is one of the key facts for this hackathon that you're participating in, responsibility, transparency, and actionability. So just making clients and customer and users aware what your energy and carbon budget is for the devices that you're using is paramount, because then they can make informed actions or even start a discussion around, can we bring that down? Is this maybe too much or is this too low? And you as an engineer have the responsibility for these emissions to also be communicated. And how that works, I will tell you, for instance, in this slide deck, because some other great people have already thought about this and create something like a standard how you can report emissions of a digital product. So the entry question of this talk is, Sorry, one slide back. So the entry question, what is the goal of this talk? So what do I want you to know and to be able to procure after you have heard this talk from me? So I want to get you to a point where you can make a CO2 or a carbon claim about your company, your product that you're developing, or about the tool that you're developing in this particular hackathon, right? So no matter if you're participating purely privately or through a company, or you are somewhere as an intern or whatever, this is the stuff that I want to get you to. I want to get you to say something like the operation that the tool that I'm producing consumes XXX tons of CO2 per year, or a request to an internal AI model that you have been focusing on or that you have been developing throughout this hackathon costs XX gram of carbon, or a customer journey in let's say some arbitrary tool that you're developing costs carbon, right? Or a GitLab pipeline, which is the testing part of the software that you might be producing, costs this amount of carbon. And I hope you get the general idea. It's always a use case tied to a number of carbon, right? So what are you doing? What problem are you trying to solve? Or what request have you become from the customer? And how does this relate to a carbon number? The idea here is to make not only saying, okay, there is a carbon number and this stands for the company as a whole, but really to define something like a use case. And the use case could also be something like a 24-hour operation, but it's very often more something customer or product usage focused. So this is where I want to get you to. And the question now is, how can we produce such a number for a software or a digital product in a standardized and comparable way? As I said already before, some other great people have already thought about this and created something like a standard that can be used. And the standard that I want to present to you today, because we believe, or I believe, that it is the typical norm, how most people understand carbon emissions for software products, is the SCI. So the SCI stands for Software Carbon Intensity, and it is a formula, actually pretty easy. So you see it here in the line in the top third of the slides. It just multiplies some stuff and adds some stuff. So there's no crazy mathematics in the formula. It's more like, how do we get these coefficients, right? So if you want to report what is on the left side of the equal sign, the SCI, how do we get energy consumption, emission factors, embodied emissions, and the unit of work? I'm not explaining this now here on this slide, but I think it's better if we go directly into the components in particular and then wrap it up with an example so you have understood what moving parts we need and how do we get these moving parts. So how do we get energy of a software? How do we get an emission factor, and what is that in the first place? How do we get an embodied emission? What is this? And how do we refine the use case? So let's dive in. Here is an example so we know what we want to get to. So this is basically the end goal, just so you have the target in mind, and then we dive into the components. So we want to talk about a software product, and I picked some exemplary software products here out for you. For instance, some of you might know Nextcloud. It is an open source solution, and you can compare it to something like Google Workspaces, right? Or the bigger Microsoft Suite, where you have Office products integrated, Teams products integrated, etc. So it's kind of like a team management software, if you want to say so. And what we created here, for instance, is we created here, as you can see in the bottom part of it, an SCI number for a software so that you can talk about the software with one compact number for a given use case. Maybe to make it comparable, we look at the right side. So here we see Wagtail, which is a content management system, and also WordPress, which is another content management system. And they typically deliver page requests, right? Here you have you can set up a WordPress or a shop or whatever. And the use case is the user comes into the page, sees a number, and then leaves the page sees content and then leaves the page, for instance. And just between these two, there's already a difference that, for instance, the one software, although it has the identical use case, has 18 grams of carbon per page visited. And WordPress, for instance, has 25 grams of carbon in both their default setups. So here you can see the power of the SCI. It's not only telling you something about a use case that makes it very relatable to what this software does, right? It's very, very visual, so to say, by saying, okay, if I visit one web page, this is the carbon amount that I have to pay, basically, or that is blown out into the environment. And you can also compare stuff if you give it similar scenarios, right? So this is also something that, at least in the EU, is currently very stressing because it becomes a regulatory purpose, because now also the EU or legislative bodies demand these numbers for you. So let's look into how we can create such a number for a given software piece. As I said, I want to walk you through these different components like the energy, the I, the M, and the R, and we see then how they later on glue together. So energy, well, I made here a bit of a funny slide, which you can see at the smiley at the top. So of course we get the energy somewhere, maybe from a wall plug, right? So we have a computer or we have a medical device. Of course it needs power in a form, so it has to be plugged into the wall. So there has to be a wall socket, right, where the power is coming from. Well, this is sometimes the case, and just keep this slide here more as a funny note. Of course, it is the case for servers, right? They are plugged into the wall, and you have different ways to get there. You can get something like the Amazon version. So if this is more prototyping what you're doing, maybe this is enough for you just getting a value to understand your particular device. Let's say it doesn't have a lot of fluctuation. It's always drawing the same power. Then this might be actually something you can go for. However, in industries and in servers, you typically have something like a really strong PDU. So this is something like in the middle. This is the light version, where you have something like a power bar, which has an API connection, or it has a cable you can plug into. And there you can get a more dynamic number, right? You can get it every second or so. And on the right side, the lab version, this is something more if you want to make more elaborate and micro benchmarking stuff. So this really gives you a number every 10 milliseconds or every 1 millisecond or even better. So oftentimes you have this, right? If you get a server from a vendor, typically they give you access to these devices through an API, as I said before. But more and more often, especially now in the hackathon, when you develop something on your notebook, for instance, or on your home setup, you don't typically have these devices or you don't want to shell out money. So here is another part how you can do it. The typical thing that is most seen in academic papers and also in very many of the open source projects out there is how do we actually get these numbers from something that is already in your systems available. So one system, for instance, is RAPL or RAPL. It was developed by Intel, I think something in 2012, and it basically is already an energy measurement system that is in your CPU of the device that you have at home already. So think of it as something that is on the CPU, and you can access it through Linux in the file system, or Windows has a small tool where you can access it through like a GUI application, and it basically tells you how much the whole CPUs in your systems are using, how much the memory in your system is using, and also how much the GPUs in your system is using. And we will see a later example in the tools section how you can actually get to these numbers. But the main takeaway here is you most likely have already a system at home that can already measure this energy. So you're all set to go when you're starting in the hackathon, and we'll want to create some transparency numbers around energy and carbon at home. So this, as I said, this is developed by Intel, but it's also available in AMD CPUs, I think since 2015. So there is a fair chance that most of you have a system that is newer than that. And also if you have ARM machines, like for instance, I do have a MacBook, there's also a comparable system in there that gives you these numbers on the command line directly spit out without you having to buy new equipment for it. If you are, however, in restricted environments or you're working with medical devices that maybe run not on chips, like for instance from Intel or AMD, there is also another way to get it. And I want to first of all outline here the approach. So if you know how much a system is typically using, of course you can create something like a power curve or a machine learning model from it that will tell you, okay, like this is how the system is behaving on 10% utilization, on 20%, on 30, or on 40%. And then you can say, okay, now I know how the system is behaving. So what I will do is I will just log all this information, right? And then next time when I'm at 10%, I know how much this equals into power. What I've outlined here in the slides is just from an information purpose, how these power curves sometimes look, right? They can be quite linear, as here in the first place, and they can also be strongly linear, like here in the middle one, where you can see it's very linear until the middle, and then it makes a very big bump to the right, which indicates that at some point, the system is using vastly more power to just provide another 10% of CPU utilization, so it uses way more energy. And if you're using, for instance, a smaller system, I don't know what system you're targeting, but let's say, for example, a microcontroller or a Raspberry Pi or whatever, you can create these power curves with just a small script that I will also tell you later on. And then you can later on make an estimation of how much energy will be used for a particular use case, and then give this out, for instance, in a hackathon, or later on also to a customer, right? So basically a before and an after setup. So obviously what I want to bring you to, as I said it before, I want to bring you to tools that you can also use directly. So we, for instance, as Green Coding, and I see here that there is here two things still in German, so let me correct that right after, but take it now for me for the moment. So what we did is we did a tool that is called Cloud Energy, and it's also available on GitHub. So basically what we did is we created the machine learning that I was telling beforehand, and you can then just say, okay, given, let's say, a certain machine that I will be running on, how much energy am I using at the moment, right? It will auto-detect everything in your system and then give you an information about how much energy consumption this is, given that you don't have a power meter or you maybe don't have a CPU that supports something like this Intel RAPL that I've told you about. So this here just a bit of boilerplate. As I said, slides are for takeaway, and also this stuff is available on GitHub and on our webpage if you, for instance, want to use this particular approach. So now I've talked a lot about energy, and I hope I could get the message across. There is a different way to get this to this component, and this is a crucial component we need, right? When we want to talk about carbon and about sustainability, we need to know how much energy our devices are using. Like either we get it from the data center we are running in through something like a power measurement, or we have a power meter that we can connect to the device we are using, or we use Intel RAPL, or we use something like a machine learning or a power curve, etc., which I also will present the tools later on, that can get us to this value. So now we need the next part, right? So we know now the energy that the system is using, but also, of course, the system is running for a particular hardware, right? So, and when we talk about hardware, what we have to factor in is that the hardware had to be produced, right? Like somebody had to forge the steel, somebody had to get the minerals out of the earth, like lithium and all the other pieces, which are typically very carbon heavy to mine in the first place. And to bring all this together and transport the product to the location where you use it, be it your place at home or be it the data center or to whatever, like all these carbon costs for producing and transportation and whatever, they are called the embodied carbon. So the carbon that had already to be put into the atmosphere just to bring this product into place. So the question is now, how can you get these numbers, right? Because obviously there are a lot of moving parts, probably very many vendors like Dell is producing this product, and now you have a computer in front of you. How can I tell what this computer or the monitor that you're looking on, how much carbon was used to produce it? So the answer here is actually pretty simple, but I wanted to outline first of all what embodied carbon is. The answer is there are databases. So what you typically would do is you would go to a database, like for instance, if you have a Microsoft notebook or a Microsoft system, they have a database you can go to. I've also put in a link from Dell where they also publish a lot more. And there's many, 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 many more. The takeaway from this slide in particular is my recommendation, especially for you for the hackathon, is go to one of the most accredited open source data sources, which is from Boa Vista. It's a French, I think, nonprofit. And especially here in the EU, the French people are already very much advanced when it comes to sustainability, have already very many rules in place that, for instance, Netflix in France has to tell every customer how much an hour of streaming costs in carbon, right? So because they have this regulation, there is also a lot of proliferation of companies who can create these databases. And Boa Vista is one of the companies that had decided to make it open source. So when you come to this link here also in the source, and I can also, I will put it later also in the chat, then you can click your server together. You can say, okay, the system I'm running on has this CPU, this amount of memory, this amount of hard disks, it runs on this frequency, and I want to use it for time X or Z, right? And what you get then is basically the cost of the manufacturing. So you get the information how much CO2 had to be used to produce this particular device, right? In your case, for a medical product, it is now pretty easy, right? Because this is the medical product you're doing. Let's say it is an insulin pump or something that could be the medical product. So this would then totally, all of this carbon cost would then totally allot for the product that you're targeting. But let's say you use a cloud service, right? And there is a computer and there are like 50 other clients on the server and you only use it for 10 minutes, right? The question is then, does everything of this has to be put into my books? Like, am I responsible for the whole server that is in the cloud just because I use it for 10 minutes? Well, what comes into place here and, oh, okay. Let me skip this here a little. Okay, it comes later on, so sorry for the digression here, but let me explain this thought that I have. So obviously you are not responsible for this whole server when you just use it for this 10 minutes, right? The approach that is done here, and I will do this also in an example calculation a couple of slides ahead, this is why I had to quickly skip through, is that you say, okay, I know that this server is used for 4 years. So 4 years is the global average for a server, for instance. And probably you know best what the devices that you're looking for then later, be it a medical product or whatever, will be used. Like, is it a year? Is it 5 years? Is it 10 years? And then you basically say, okay, let's say it's 100 kilos and I know it's used for 1 year, right? But I'm only using it for 1/10 of the year, right? Not longer. I'm just using it for 1/10. Then in your books comes only this prorated amount, right? Like only the 1/10 you're actually using for. And you can think about making this more granular if you say, okay, from this 1 year or from this 4 year, I'm only using it for 10 seconds, same calculation, right? You just calculate it down to the second, multiply it with the time you're using it, and you prorate it to the time that is actually in your books. And this methodology is used in the SCI in particular. It is also used in some bigger concepts for people of you that maybe have um, already looked into some like calculation methods. There's something like the GHG protocol or ISO norms. It's always very similar. So you always use your timeshare of the particular product, and this is the carbon you have to communicate to the outside world and also the customer. So now we've looked at two components, right? We have looked at the energy. So how much is the system really drawing that I'm using, and the software, like how much is the software pulling, demanding in terms of energy that the hardware has to use, and also how much manufacturing cost has been created. So how much carbon was needed in order to produce the device. So now you can say, okay, I know now the energy that I'm drawing, but doesn't it differ? Like if I run the product, let's say in India, I will probably get a different kind of power, like more renewable or less renewable than in a different country, right? Let's say if I go to Australia, or let's say if I go to China, or even if I go to Europe or the US, obviously they create power with a different, so to say, intensity or grid mix. And the idea here is the following. You can, if you have the capabilities, let's say there is an API behind the medical product, behind the medical tool that you're building something like an API for, and this API can run in different places, right? It can run, for instance, in Germany, but it can also run in India. And what you're getting is a very different power that has been used in order to power this server now in this particular case, right? So here I have an example, which is in Germany, and here is a number on the right side, which says 167 grams of carbon intensity. So what this means is that for 1 kWh that you will draw from the grid, 167 grams of carbon had to be put into the atmosphere, right? So the mix in Germany was then at this point probably a bit of coal and probably a bit of gas, but probably also very renewable, right? You see it on the color, it's kind of yellow. And for people who have a second tab open, you can also go to a site which is called electricitymaps.com. And what you will see there is you will see a map of the world, and you will see a difference. Like in this country, for instance, the power is, I don't know, 800 grams of carbon per kilowatt hour. And in another country, you have 50 or you have 20. So you can already see where I'm going with this idea. So the SCI demands that you say, okay, from which power grid am I drawing the energy? Because this is very relevant when it comes to carbon, with the idea to use more renewable or to incentivize people to use more renewable energy, right? But also you can see some optimization potential. Like if you have the ability for your API that powers your medical device, for instance, go to a different country or use it at a different time, you can save a lot of carbon, right? And I will come later to an example how we do that particularly. So now the last piece that we need in order to create the SCI formula is the use case, right? So every software product and also medical products do not run into a vacuum. Let's say if you have an insulin pump, as an example for a medical product, your use case would be delivering 1 dose of insulin, right? Or let's say keeping insulin levels stable over 24 hours. And the question is then, okay, for this particular use case, what is the carbon amount? So you always have to communicate what you're doing or what you're looking on if you communicate a carbon number to the outside world. Like it cannot just be 2 grams of carbon, like my software is using 2 grams of carbon, you also have to say what you're doing with the software, because it can be very different to different people what they do with a particular software product, right? So here an example, just so you have an idea how, for instance, we did this, how we standardized this, for instance, with SCI, and how it can also differ between software products. Like we have been looking at 2 databases, PostgreSQL and MariaDB here in this concrete example. And what happens here is that we used a standardized benchmark. So because you cannot just say, okay, my database uses this amount of carbon, you have to say, okay, what am I doing with the database? Am I just reading? Am I just writing? Am I doing a mix of all? Like, what am I doing? So luckily, some other people have already created something like a standardized benchmark. This is called TPCC. Just take it for granted now that this is the name. But effectively, what they're doing is they are creating some databases, inserting some data, reading it back out, and deleting it again, right? And then we have created two use cases on these by running an SCI score for this particular test. And you can see here that the carbon amount differs vastly. So the one database has 160 gram per operation and the other one 29 gram. So this is very common that software products have very different carbon cases, although they kind of do the same thing from the customer or from the end user perspective. Yeah. So here the takeaway is, especially when you're going to the hackathon, look for something that is either the use case of what you are exactly building, or if you don't have that, because you're creating something where you don't really know what might be the end use case, right? Like something like an intermediary product, go for standards, go for standardized benchmarks. So if you find already something that says, okay, there is a load test for this type of medical product, medical software that I'm doing, then take it and create an SCI score for that, because this gives the most accurate and reproducible representation of the carbon profile of what you will be creating for the hackathon. So this is the takeaway from this slide. And to give you more of an idea that also it might be helpful to have more than one use case, right? Especially in a database, it was a very confined example, right? A database has typically this read, create, update, and delete use case. However, if you look at a more multidimensional application, like for instance, here I gave you a use case of WhatsApp versus Telegram, you can make a wider picture. So for instance, WhatsApp, you can say, okay, WhatsApp is better than Telegram, or WhatsApp uses less energy than Telegram. But the question is, what are you doing with the application, right? Are you doing a messaging? Like, do you just send text, or do you make video calls constantly with your partner? Or do you call with the application, or are you constantly in group chats? So here you can see that it might change. Like it might be that Telegram is better in messaging, but it can be worse in video. Actually, here in this example, it is exactly the other way around. Funny. So let me rephrase that. So Telegram could be way worse in video, but could be way better in messaging, because messaging here is the lower part of the spider web diagram. And the idea here is use cases matter, and it might also be beneficial if you create 2 or 3, because this gives a more wholesome and better understandable picture for the person then later on maybe selecting your medical software or your medical product from a sustainability point of view. So just one small digression, because I know medical devices send a lot of data. It is a very important point, right? Getting data from A to B, telemetry, big chunk of what medical devices often are. So let me just explain you how green coding, or the sustainability realm, tries to look at the network issue. So the approach was actually invented by the Shift project, something like in 2009, and it's very hard to say how much it will actually really cost you if you send, let's say, a megabyte from A to B, right? So what they did is they created something like a 1 byte model, which gives you something like a ratio where you can later say, okay, I will send 2 megabytes over the wire. How much energy do I have to use on average in order to do so, right? The number here is called, that I outlined here is 0.0023. However, and I will put here also a link to that in the chat, the numbers differ depending on what use case you're doing. The most accurate number we have actually put on our webpage, the green coding IO/CO2 formulas. And I think the current number is something, let me quickly look it up on my second monitor. So the current number is something like 0.0026, whatever, yeah, kilowatt hours per gigabyte. But the idea is the following. So if you send data over, you will just apply a multiplication. So you will say, okay, I don't need to measure energy. I don't need to measure embodied carbon. Somebody else has produced an average number for this particular segment of the ICT, of the information and communication technology sector, and I can just use that. And very many tools that, for instance, evaluate websites. So if you want to create something like a website front end for the hackathon, use that, and you can just plug a URL in and you get a number for that. And if you have a medical device or a medical software that sends telemetry data, average over all of this and then just multiply it with a number, and you directly have the energy where you want to go to. I don't want to go into too much detail whether the pros and cons of this approach. There are also other approaches, but this is the typically widely accepted approach at the moment where you can get an energy information about network data. And as I said, also, we will probably have a bit of time for Q&A. I see that you already are posting questions in the chat. I will try to take them if we have the time for it. But also the offer I want to uphold, you will have later, for instance, my contact data in slide deck. And there is some capacity from our side to answer some questions. And I'm also happy to point to some tools if you're missing something particular. So also feel free to shoot a message later on if something was unclear in the slide deck, or maybe you need a pointer to a very specific tool or use case you're currently working on. So hopping to the next slide. So now we have all the parts in place, right? We have talked about energy, we have talked about the grid intensity, we have talked about the embodied carbon, which was the manufacturing of the whole hardware equipment, and we have defined a use case, or let's say we know what a use case is. Now let me walk you through an example. Let's say we have an order in an online store, right? Not a typical medical example, but I wanted to make it more general because I don't know what you have for medical software, medical products in mind. So I want to make it general so everybody understands it, because I think everybody knows what an online store is, if not have ordered from an online store. So R, the use case. This one's pretty clear. What we want to tell to our customer of this online store is, hey, if you shop on our site, if you go through all the process, like going through all the pages and then clicking put into the cart and the checkout, how much carbon will this cost, right? So this is the use case we are tracking. And we're doing this by, let's say, having a power meter attached to the server in particular that will give us some information throughout this customer going through this whole process, right? So how you set it up is basically the software part, but what I want to get to you, what I want to get across is how do you make an SCI for it. In this example, I've said, okay, the server that this particular customer is ordering from is in Germany, right? So the current electricity mix in Germany, I have now used from this API that I showed you, so electricity maps. And this has told me Germany is at the moment at 250 grams of carbon per kilowatt hour. And according to the Data Vista tool, which I've already shown you before, the server that I'm using is in place for 4 years. As I said, this is the typical global average for most data center. And the order and Data Vista says, okay, this server needed 350 kilograms to produce, and this will then be prorated over these 4 years. So if my part only takes 10 minutes, right, I have to, and here you see the multiplication that I'm doing, I have to multiply these 10 minutes by the prorated amount, and I will get to a number 1.674 grams of carbon for these particular 10 minutes that the server has been used. I mean, I think it's pretty easy to understand if you look at these slides later on when you have a couple of minutes and could breathe through a little, but the general mathematical approach here is pretty simple. And then, as I said before, like somehow you have to measure the energy with the tools that I've presented to you before, like RAPL, or you make an estimation, or etc. I've also seen that somebody had put a question about how to do it for a Raspberry Pi. I will also share a tool on this later on. But let's say for this particular example, now we got 30 watts, we multiply it by the 10 minutes, we get a kilowatt hour value out, and then we add everything together. So the SCI for this particular example would be 2.942 grams of CO2 per order, right? Because the order in the online store was where we wanted to get to. And coming to a medical device example again, the question is then, what is the use case, right? If it's an insulin pump use case, you could say, okay, per one dose given, and then obviously all these numbers will probably change, but the idea and the approach is the same. So I hope by walking you through this example and also making it clear how these pieces come together, now we have a foundation that this SCI is a usable form to talk about software and digital products and how these values come together. Okay, now let's see some tools and also let's see some potentials where it can be used. So I said already, if you have like a Linux system, it's pretty easy to get these numbers from RAPL, for instance, out of the system. So one tool to use is called, for instance, perf events. So perf events comes with every modern Linux distribution and is also available on, for instance, a Raspberry Pi system. However, a Raspberry Pi in this particular example might not have an Intel CPU, so you might be out of luck for this one. But if you have any mobile device which powers an AMD or an Intel small chip, this is the tool to use. So it could also be, as I said, a desktop computer, a server, they all have this capability. So what you just say is you type a command in like here. Here I have given you an example command that will give you the power of the whole CPU. And whatever process you run after will then be given a value, right? Of course, you have to dig into this when you start the hackathon. So again, what I want to get across here is give you an example that these tools exist, and then you can dive into the documentation, how to particularly use them. So this is a super easy one-liner. We'll give you a validated approach to get the energy, and it's available in basically every modern Linux system that you will probably be using. If you don't have a Linux system, for instance, and you want to still get a number, or if you're in a confined environment where you don't have access to what perf events, for instance, requires, you can also use multi-operating system tools, right? They run on every platform. They run on Windows, they run on Mac, they also run on Solaris if you have old systems. They run basically everywhere where Python is available, right? So here in this example, I've linked this also out here in the bottom. So the URL where we have this model, this cloud energy that I told earlier before, you just go to github.com green coding solutions cloud energy, and there is a very extensive documentation for it. But here in the screenshot, the gist is you just start the model. So you just say Python 3 XGB. It will then be pre-trained on the parameters that it has auto-detected on your system. And then you can say, okay, I will have at the moment 10% utilization. How much power would that be, right? So you directly get a power value out, and it just goes like this. Actually, maybe we have the small time here to make a small demo how this looks like. So I think you can all see my screen. So the idea here, if you have this cloud energy then here checked out, you can just say Python 3 xgb.py and sorry, source command bin activate. Hopefully it will work now. No, Python 3 pip install requirements. Oops. So actually, I think it might be a bit tricky to try it out now, but I will give it one more go. No, sorry. I have to install a couple of packages. So as you can see, there is an install procedure, obviously entailed with the model. But what you do is you basically just plug this in. And then in this model example here, as you can also give it more parameters. Like you can, for instance, say you have a RAM of, let's say, 1 GB. And you can also say, and I make this here a bit bigger, I have a CPU frequency of currently 3000. And then it will give you a better estimation of what your system is currently running. You can also say my CPU make is like an Intel system, in Intel, and then it will concretely go for Intel systems and give you a better estimation of what is currently going on. So the more information you give it, the better of an estimation it can give you. And yeah, and this is what I wanted to get across. So these tools are free and open source to use. They just run on Python, and they give you all the information you need in order to create something like a power if you are on a restricted system. However, my recommendation would be if you can actually get a power number from RAPL, you should do so, because this obviously is a better thing to get the data from. So let me quickly here go into the slides, because sometimes my mouse cursor loses focus. Okay, if you are already in a Python system, right, the question is then, okay, Arne said, you should probably go for measurement if you can, probably RAPL if it's possible, or if you're even training an AI model, like are you then maybe even going for an NVIDIA system and you need GPU support? Well, you're in luck. There are tools like CodeCarbon.io, for instance, that directly work in Python. And you can think of it like a debug statement. You just say, okay, start the measurement here and end the measurement here and tell me everything that was in between. I just want to get the energy from these 2 points in time. And CodeCarbon.io, for instance, can do that to you. It works directly in your IDE because it is an import, and it's very directly connected to REPL and can also get the information from NVIDIA cards. Another thing is if you have something that is in the cloud, right, and you maybe don't have access because you use only software as a, sorry, not software as a service. If you use a function as a service, which is in something like Lambda, you can use something like Cloud Carbon Footprint. So Cloud Carbon Footprint hooks directly into the cloud service and gives you an estimation of how much your current cloud setup is using. So you can also break this down on a service level, and you can also use something like labels, and then basically getting to the point where you can say, okay, I'm using a part of storage on S3 and I'm using a bit of functions in Lambda. How much carbon is this? Because this is the project that I'm currently doing for the hackathon, right? So this is something if you're in the cloud as a tool. Also, as I said, most of this, everything I present today is free and open source to use. Also this one. So Cloud Carbon Footprint here in the bottom link has a very extensive methodology how they do it. And it works for very many of their products already. So now we come to the juicy part when it comes to network. I already foreshadowed this a bit. Like there are tools like Website Carbon, for instance, and you can also open a second tab now on your systems and go there, and on Website Carbon, you just plug a domain in. You just say, hey, I want to know for, let's say, Hacker Earth, yeah, the website, like how much carbon is the website using, right? You plug it in, it will run through, and it will create this network measurement methodology that I explained to you beforehand. And you get the information, okay, how much carbon is this website emitting for one visit? So here the use case would be a visit, and then they make an energy estimation through this network formula that I told you about. So also something if you want to create a web front end, very easy tool to use, and you can create some very viable number that will hopefully help you in your hackathon project. So now that we've gone through all the methodology parts, I want to leave you with some pointers and some ideas how you can also then look into optimization, right? So key challenge at the hackathon is the transparency and the communication, because this is, as I said, one big part of green coding, also creating the shared responsibility that you are responsible for telling the end user how much carbon it is using. But also we want to optimize at some point, right? We want to get emissions down. So how can, for instance, some techniques be applied? So what I've already told before, there are the potentials that we call in the Greek coding domain shifting potentials. So you can either shift in time by running a workload at a different time, if possible, or you can shift in location if it is possible for you, right? Sometimes it is not because of compliance regulation, like you cannot just go, for instance, from Europe to Russia. So this will not work, like the EU does, for instance, very often not allow this for certain workloads. But for instance, inside of the EU, it's pretty easy, or inside of India, it's also pretty easy to shift the load from one location to another. And then for Europe, I have here given the example. In this particular point in time, it was the case that in Germany, for instance, there was a carbon intensity of 250 grams, but in Finland, it was only 68. So what we could do is we could say, hey, we're just going to Finland with this particular workload. Let's say this is a training of an AI model or creating a knowledge base or whatever you need for your medical product, and you can go over. Yeah. India, also the same. You have very many different parts of India, and they all have a different carbon potential. And the same thing goes for time. Like you can also say, okay, I cannot leave the location where I'm in, but I can change the point in time where I'm doing this. So for instance, Germany has a lot of solar, right? So if you're doing this in the middle of the day, you will get a better carbon profile. But if you're doing this during the night, when there is no light or no sun at least, you will get a higher carbon intensity. And the same thing is probably the case for India, where you have different points of the day. And I encourage you to go, for instance, to electricitymaps.com and just see how this changes over time to get a glimpse in particular where you can get a potential to reduce the amount of carbon of how your medical software or product is used. The next idea, and I think I've already talked extensively about this and would rather take the time for some questions, like use something like a labeling mechanism, put it into your repository, put it where this software or this product is used, and communicate it to the customer in a very easy and concise form. The methodology that I presented is the SCI, but obviously there is more to that. And then you bring it into something that directly ships with your product. And also something that you always want to avoid, right? Let's say you just create a documentation page for your medical product or something like this. Always bring it to a tool like Website Carbon, for instance, and look how much carbon this front end is emitting. So it can be the front end for your device or for your software, or just a documentation page, because what I've put in here is an example from a customer we had in Germany, and they launched a sustainability page. and they rate it as one of the worst pages that, for instance, this calculator knows. So this is something like a marketing fuck up that you typically want to avoid just by pumping your tools very quick, your products very quickly to these estimation tools. Also, another tool that I've just quickly highlighted, if you have like a distributed system, there's also another idea on our webpage. Feel free to dig this up. I think in the interest of time, I would also keep it here brief. Like you can also bring together, if you have very many smaller medical devices or medical software products that are used to bring one bigger project together, there's also tools to help you aggregate this data, right? So CarbonDB is one of them, but there's also a lot of others out there. As I said, my idea here in this talk is to give you some pointers, what tools are out there, and get your ideas flowing, because you probably know best what is best for what you want to create. And here I just have some example why it's extremely important to look at energy consumptions and carbon emissions. For instance, Siemens recently moved to an ultrasound machine with a very low boot time, and it also enables you to turn your device off, right? So here the focus, for instance, is on energy saving in particular. As I said before, like there are these different domains. You can save purely carbon, purely energy, or you can also save carbon through the manufacturing of the device. Here, for instance, Siemens has gone the route by also making the device turn off if it is needed to. Like very often medical devices are powered on, constantly on, and never turn off, right? So if you want to look also into the optimization field, I can also encourage you like highlight if you have these functionalities, like if whatever you're creating can save carbon or energy, highlight these in particular, and also make it clear through the SCI how much you save, right? Like if you develop something new for a tool that's already existing and that it can now turn off, show this difference, like show the people what you have achieved. And this is, for instance, an example from Siemens already in the industry, but it's still very rare. So I encourage you, the hackathon might be a goal to go there. And also something because of the high power usage, like I think we've already talked quite a bit about this, but high power is a huge saving potential, right? You as an engineer can contribute how much power these devices are drawing, but many engineers are not aware how much energy their systems are consuming. So using something like the SCI does not only encourage the client, but it also encourages your co-engineers because they see, oh, wow, they are giving out a number for this. I want that too, right? So, and this is very particular in the medical device field where this has been neglected for quite a while. So this hackathon is a very nice use case to create SCI values for these products and then also draw attention to this very underrepresented transparency topic. So summary, transparency is key. Tools are easily accessible, most of them open source. Approaches are diverse. I showed you some measurement approaches, estimation, but approximation approaches also. Showed you these databases that you can go for. And medical devices have a huge potential for carbon savings because it's still very underrepresented and has very many unlifted opportunities. So sustainability is an edge that is coming more and more, be it through regulation or through customer demand. And I hope I could leave you with some interesting material and some interesting pointers, and would like to thank you very much for listening to my talk. Also, if you watch me talk it again in your recorded copy at home, also very nice. But here are some pointers to our projects and tools and where you can get more information. But also, as I said, shoot me an email if something was particularly missing. And I will now try to look in the chat. And first of all, thank you very much for being part of this whirlwind tour with me. And I hope I could give you all the pointers that you need in order to facilitate, in order to dig through the hackathon and create something viable. Thank you.
Thank you for the presentation. I think we have a couple of questions if you want to sort through the chat there. I think a couple of them that you've covered throughout the deck. And if anyone has any last minute questions, of course, we're welcome or happy to take them as well.
Okay. Cool. I think it's easiest if I just read them out, if you're okay with that.
Absolutely.
Cool. Let me start from the beginning. Hi, I'm an AI assistant. Okay, that's probably something else. If there are any questions, feel free. Can I get a certificate? Hey everyone, thank you for joining us today. Also, no, here. Can you share some best practices for integrating green coding principles into existing software projects? What are some notable success stories or case studies where your tools significantly reduce the energy consumption of software? So I can direct you, for instance, to something like the Green Software Foundation is very strong when it comes to creating something like a patterns catalog. So because you ask for best practices in particular, like this is a very nice go-to location. Green Software Foundation, as I said just briefly, is a conglomerate, or as more like a foundation. Conglomerate, see the wrong term, where there's like GitHub in it, Microsoft in it, Google is in there, and very many big players. And they are not only creating this standard that I presented to you, but they are also creating these best practices, right? So some of them flow, for instance, into our tool, and we have something like an optimization feature in there, but also we have added a lot of more of them. And there's also best practices in our documentation. So if you go, for instance, here to the docs, there is a part where you can go for best practices and look there how we approach this in particular. And then the second part of the question was, let me quickly look it up again, notable success stories. So if you go to the Green Software Foundation webpage, they present these success stories in their article section. So I will bring here this here up. So sometimes the sometimes the members of the Green Software Foundation take very different approaches. Sometimes they have pipelines running and can reduce that by 50 or by 80%. Also, if I find it later, I'll also share something from Mozilla where they reduce their pipeline cost, for instance, by 90% just by using efficiency gains. But also there are data centers in the Green Software Foundation who use their hardware for longer, right? Who say, hey, we are not procuring every 4 years, we're procuring every 6 years. And by that, reducing the carbon footprint by 50% in the embodied part, right? And as I said, here in Europe, there's also moving workloads from A to B. Like, be sure to check that out because this has a lot of success stories if you want to follow along them. But I hope I also got you some pointers to create new success stories on your own throughout the hackathon. Cool. Next question. How do you calculate for Raspberry Pi? The tool I have here in mind is Power Jeweler, and I think this is the web page in particular. So this can create these power curves, as I told you before, for Raspberry Pi systems. So what it does is it will basically 1%, 2%, 3%, 4% is it will go through all the different percentage steps of the CPU. Since it's a very simple processor, there's not a lot of fluctuation, so it will always create the same energy load. And then we'll create you something like a lookup table later on where you can then just say, okay, given 2% utilization, this is the amount of power the system is drawing. And this approach goes for all microcontrollers. So it doesn't have to be a Raspberry Pi. So if you have something that is even smaller, like an Atmel system or whatever, can also work. So this is a very versatile tool. And I hope this, yeah, I think this answers your questions, I hope, very concisely.
We've got time for one last question. There is
one last question. Okay, let me quickly zoom. Hi, Arne. We code at specific locations where electricity is used only for the purpose of developing a specific software. So here there will be the overall SCI included, the other peripherals that we use other than the existing machines, example, the coffee machine as well. This is an interesting question. This depends a bit of what you want to report. So typically the approach in the SCI is you only factor in what was needed in order to create your particular software product. So you can say, I cannot develop software without my coffee machine, and then you can factor it in, right? But this is typically not how the reporting works. So the coffee machine is typically part of the greater context. So this would be your employer, or if you have a rented office, your office renter in particular, and will not be factored in into this particular software product. This is how, at least how the SCI works.
So we got 2 last-minute questions that came in here, and I think they're really good ones. So I think we should probably address those.
Okay, let me try. What advancements do you foresee in the field of sustainable software engineering in the next 5 years? And you mentioned in one of your slides that we can import certain library and see how much emission certain parts of my code does. Can we get that library? So what I mentioned was that you can use Code Carbon, and you will find it in the slides. So I can keep that here very brief. So Code Carbon is a library you can import and then measure different libraries. So this is where you want to go. And what advancements do you foresee in the field of sustainable software engineering in the next 5 years? So the biggest part that will come is like you will have, for instance, carbon-aware systems, so that Google or all the other big players will give you access to their systems and make carbon-aware decisions. For instance, we are currently working with GitHub at the moment. Probably some of you use it, and then you have these actions, so that you have these CI/CD pipelines. And we want to bring them to the point where they create something like a badge that you can click and say, hey, you know what? I can actually wait for 2 hours. It's not that time critical, but I want to save the most amount of carbon. And then they schedule it because they know best, right, when they have low carbon, to the best carbon period of time. So this is, for instance, an example, and I think we're out of time, so I'll keep it brief for this one.
Great. I just wanted to thank you for your time this morning and for the great presentation. Again, if anyone has any questions, Arne's contact information is there, and we will be sharing the deck with everyone. So thank you, everyone, for spending the last hour with us, and we hope to see your ideas come to life.
Thank
Cool.
you,
Thank you,
Annie. Thank
everyone.
you, Amanda, for the wonderful session. And of course, if you have any more questions, you guys can shoot a text to Arnie and he'll be happy to take those up. So, with that being said, this is me, Rico from Hackers, signing off. And thank you, Adarsh, for co hosting this session with me. Once again, thank you, Annie. Thank you, Amanda. And you all have a great day.
Thank you.